Swayam Prabha. Digital India. Educated India.
So till now, we have looked at how to get into R through a GUI, define variables, work with variables, access different elements in variables and so on, different types of variables, and how to do matrix arithmetic and so on. After this, the next logical step is to actually do programming in R, where you write your own code to either access inbuilt functions in R to do data analytics, or you write your own algorithms for data analytics. So we're going to show you very, very simple ideas in programming in R. Much like every other programming language, these constructs are very similar. We have this if-then-else construct, which basically implements certain set of steps if certain statements are found to be true, and comes out if they are not found to be true, and so on. We will look at the control structures and simple snippets of R codes that implement these kinds of control structures. The most important control structure is if-else family of constructs. This is something that we have all seen in other programming languages. The construct is very simple. If condition is true, then go through a set of statements. So if you had just if, then that condition is verified. If it's verified to be true, the statements are implemented. If it's verified to be false, then it comes out of the loop and goes on to the next line of the code. Now you could also have if, else, which says if these conditions are true, do this. If these conditions are not true, I have something else for you to do, which are the alternate statements that we have. Now you could have more than one if-else condition. You could have if, do this, else if, another set of conditions, do that. If both these set of conditions are false, then do alternate statements. So these are standard constructs that we have seen in other programming languages. In terms of R code, a simple if, else if example, x equal to 6, if x is greater than 7, x equal to x plus 1. So that's a logical statement that you're verifying. The next one is an assignment statement based on whether the logical statement turned out to be true or not. You could nest another else if x is greater than 8, do something, else do x equal to x plus 3. Now since x equal to 6, the first condition 6 is not greater than 7, so that statement is not going to be executed. 6 is not greater than 8, else if is also not going to be executed. So you'll come to else, which is x equal to x plus 3, so you get the answer 9. For loop is very similar, where you basically have a sequence and then say for some number to some number, keep doing this. Okay, so there's a from, which is starting number, to, which is an ending number, and by is the increment or decrement that you use. So for this sequence of numbers, you keep repeating the statement again and again is what the for loop construct is. You could have, much like what we talked about in terms of if, else if, and so on, you could have nested for loops. You could have an outer for loop with an iteration looking at a certain sequence 1. You could have an inner loop which is looking at another sequence 2, and then you have a set of statements which keep getting implemented as we go through these for loops. So here is a very simple example. N equal to 5, sum equal to 0, for I in sequence n, n, 1. What does this mean? So basically what we are saying is the first number is 1, the last number is 5, n equal to 5, and use an increment of 1. So this is going to run for I starting from 1, 2, 3, 4, and 5. So when you run this code, you see the result on the right hand side. When the first iteration goes on, since sum was 0, I was 1, you will get the result 1, sum plus I. In the second iteration, you get I equal to 2, sum is already 1, so 1 plus 2 equal to 3, and so on. So you have the sequence. So this is very simple for loop that you can write in R. Now in many cases, you might also have situations where while you are interested in running the code for a certain sequence of numbers, you want to come out of the loop if there are other conditions that turn out to be true. So you want to break out of the loop. So what you could do is you could use a if statement within a for loop and then use a break to come out of the loop. So here is an example, n equal to 100, sum equal to 0. For I in sequence 1 comma n, which basically means that this iteration on I will keep going as 1, 2, 3, 4, all the way up to 100, sum equal to sum plus I. And then the next command says print the sum. Now at some point it says if sum becomes greater than 15, then stop this iteration and break out of this. Now if these commands were not there, the result would have been for the loop variable to go from all the way from 1 to 100, you would have had all of these sums computed. But in this case, at I equal to 6, you have the sum which is 21. Once that is computed, then the if statement is seen and 21 is greater than 15. So you break out of the loop and come out. So this is way in which you could actually have for loops where based on conditional statements, you can stop the for loop and then go forward in your code. Very similarly, while loop is you keep doing something till a condition gets satisfied. And once the condition gets satisfied, you come out of the loop. Till then, you keep looping inside. So here is an example. Sum is 0, I equal to 0. Final sum is 15, very similar to the last example that we had. Now, while sum is less than final sum, you keep doing I equal to I plus 1. And sum equal to sum plus I. So when you start this, you start with 1, sum is 1, and then you keep going on. And you notice in the result, once sum becomes 15, this loop stops because this loop says you should keep doing this only till the sum is less than 15. Once you are beyond 15, this loop stops doing what it is doing.